Lesson 18. In this lesson, we're going to be looking at a case study of a validation for a tablet press. So we're going to be looking at how do you go about performing a validation. So we're looking at the project from start right through to the process validation. So we'll be looking at the V model, so installation specification, our operational qualification, and our performance specification. So here's a little video that explains how a tablet press works.
Fill position, the lower punch is pulled down by the fill cam as the die is passing under the feed frame. Product enters the die bore by gravity. The weight adjustment cam next raises the lower punch, which pushes excess powder out of the fill die. After the die leaves the area of the feed frame, a spring-loaded knife-edge blade scrapes the surface of the die and removes any excess powder. The pull-down position allows the lower punch to be pulled down slightly so that the top of the powder column in the die bore is below the surface of the die table. Simultaneously, the upper punch is lowered. The lowering of the powder column prevents any powder from being blown out of the die as the upper punch enters the die bore, thus preventing variations in tablet weight. When the upper punch enters the die, pre-compression begins. The main compression step gives the tablet its final characteristics. The final tablet thickness is determined by the distance between the punch tips. Again, in some presses, the main compression position can be monitored for automatic weight control. Before reaching the full ejection position, the upper punch is lifted out of the die bore while the lower punch is being pushed up by the ejection cam, thereby pushing the tablet out of the die.
So that explains how a tablet press works. So in the tablet press, you start off with your blended granulate, your powder coming in here through your hopper, and it goes into your product feed chute through the hopper, and it goes into the filling station as you saw in that short video. Then it goes to the compression station, and your die goes down, your powder goes in, you get your pre-compression roll, you get your full compression roll, and then your tablet is ejected out. There is a deduster generally to take any excess dust from the tablets, and then there is a tablet collection. The operation of a multi-station tablet press. So as we said, your tablet blend is in your hopper. The blend is fed into your feed mechanism or your feed frame, which facilitates the filling of the die cavities. You've got your upper punches here in your upper turret, and you've got your lower punches down here in your lower turret, and they're held into place in the die table by screws. So you saw from your video here, your feed is coming in, you've got your pre-compression roll to sort of flatten out your powder, and then you've got your main compression roll which makes your tablets. And as they come around, the tablets are ejected, and then any ones that are fed to waste that do not pass specifications will be ejected out here, and your good tablets are coming out here. So this is what it looks like from a side-on view. You fill the required amount of powder. That's important to get your right weight and your right content uniformity. You have your compression, so that's important as well to make sure that your visual and your friability and all of those characteristics of your tablet are working okay. And then you've got your ejection. So tablets that are below weight or above weight should be rejected. So you can see the tableting cycle. Your die coming down, your powder going in, the top part being scraped off, your pre-compression roll, your full compression roll, and then your tablet and it being ejected. So you are in charge of running the validation project for a tablet press in a drug product facility. What critical to quality attributes do you foresee? What will be your testing requirements for the qualification activities? And what site departments will you select to support this project? So I'd suggest that you might pause the presentation here for a couple of minutes while you give some thought to that and maybe jot down some of your answers and see how you get on as we go through the case study. Okay, so the process parameters for a tablet press. So the tablet compression variables are your fill volume, so how much powder or granulate is going into your die cavity. The compression force then, the power that you're using to compress your tablet, obviously will determine the hardness of the tablet and its friability. The turntable speed, how fast your turntable is moving during the whole process. The dwell time, how long each tablet is staying into the turret for. The granulate feed, the speed of that and the uniformity of it and the makeup of it. The ejection force used to remove the tablet, and obviously the lubrication of your excipients will be really important here. So mag stearate is often used as a lubricant for a tablet to help prevent it from sticking in the ejection cam. So your installation qualification, what would you be looking at here? So obviously you're going to be looking at the quality of your equipment finishes. It needs to be of the proper grade steel and it needs to be of a GMP standard. You need to have certification for all your product contact surfaces, particularly for your dyes, because they have very critical information. You might have the strength, the dosage of the tablet. You might have an identifier for the tablet also on your tooling. List of the equipment and spare parts. So what equipment do you need? What spare parts will you need to have going forward to maintain your tablet press? The verification of the utility requirements. So you'll need compressed air, you'll need electrics, and you'll need pneumatics as well to operate your tablet press. Have you got calibration certificates for your sensors and for all of the components relating to the tablet press? Has it been identified a unique internal identification number to be able to track it for the purposes of validation, for its calibration, its maintenances, and also for financial records? Have the P&ID drawings been included and are they verified to be correct? Have your mechanical and electrical drawings been included and have they been verified to be correct? Have your plant layout drawings been updated to include this new piece of equipment? Have your maintenance manuals been included and have they been referenced and have they been properly stored and filed? And have you verified that the correct version of the software is in place and it's up to date and it's been qualified? So when we come to our operational qualification, we're going to be looking at our OQ tests, and in this we're going to be using a placebo product, so something without the active ingredient in it. So we'll be looking for the verification of the calibration status, checking that to make sure it's checking the verification of the calibration status to make sure that it's okay. We'll be checking the maximum operation of the press speed to see what effect that has on the tablets coming out. We'll be looking at the maximum feeder speed. What effect does that have on the tablets coming out? We'll be looking at the user security level access. Have you got traceability as to what operator is operating which part of it? Is it got full traceability of all the steps that are occurring in it? And will it look for identification of password at each stage? We will test the conforming product is being produced at batch startup. So we'll be looking at the thickness, the strength of the product and the friability of the tablets and the hardness of the tablets. We'll be looking at the recording the program and the recipe for production. Are they all being controlled? Is the proper recipe being downloaded? Has it been verified and validated? We'll be looking at the integrity of the equipment and the test data during power cut conditions. So simulating a power cut to see what happens to the data. Will it be stored properly? We'll be looking at verification for all operator interventions. Obviously, we need a full audit trail on a piece of critical equipment such as this. We need to be able to show a regulator who did what steps, when they did them, what time they did them, and if operator had a changeover, we need to see where that happened, at what point in the process did that happen. So we need to verify that all the steps are individually traced for an audit trail. We need to verify that the SOP has been up to date, has been reviewed and approved and is ready to go, and that the batch documentation is all in place and has been updated. We might test the changes in the tablet fill depth, so see what difference it makes if you overfill or underfill your tablet. Will it reject the batches will it reject the tablets that you need rejecting? Test the changes in the force compression. So again, this is a critical process parameter because it affects the hardness of your tablet. Test the process capability of the tablet press for your placebo. So we're going to be testing those tablets to make sure that they're okay. Testing conforming product is produced at the end of the batch. So making sure that during the shutdown of the process that it's working as efficiently as it should in the middle. Testing the security alarms on the press. So the emergency stop, if you have product blockages, is it going to alarm? If you've got punch jamming, will it alarm? Damaged punches, will it let you know? Will the alarms work? If there's excessive weight variability, is it going to alarm? So checking all of those test security alarms as well on the tablet press. When we come to the PQ, we're going to be looking at our actual product and looking at improvements that the process can be made for our performance qualification. So we're looking here at our critical to quality characteristics. Our critical to quality characteristics are the weight of your tablet. That will determine the amount of active ingredient in it. The uniformity of the weight, obviously that needs to be standard across the batch. Our hardness is very important because that determines how it disintegrates in the body. So if it's too hard, it might disintegrate much slower and the patients mightn't be getting the optimum amount of active ingredient. The uniformity of the content is obviously really critical. That again determines your amount of active in your tablet, and the appearance of the tablet is particularly important, especially for some of the Asian markets where visual inspections would be very critical for their marketplace. The non-critical things that are important, but they're not critical process parameters, are the thickness of your tablet, your diameter, your dissolution, your disintegration, and your friability. So your friability is if you put a tablet under pressure, would pieces of it chip off and how they chip off. And our acceptance criteria is for your European Pharmacopoeia. So we're going to test the influence of the following parameters on the critical to quality characteristics. So tablet speed, the speed of the turrets, how does that affect your critical to quality characteristics? Our feeder speed, how fast the product is going in, how fast the flow is going in through the hopper. Our startup, how does the startup affect the critical to quality characteristics? Do you lose a lot of granulate during the startup? Stoppages, what happens to the tablets around the time of a stoppage? Very high rejection rate during stoppages when you're restarting and stopping a tablet press. At the end of the batch, how is your critical quality attributes looking? Are they diminishing? Are they staying static? Do they need to be altered? The tablet fill depth and the force of the compression. Those are obviously very critical for your hardness. The process capability of the tablet press with your active product in it. So how in control is your tablet press? We're going to be looking at calculating process capabilities in a further on lesson. So your process validation. So in addition to doing your performance qualification, we're going to be looking at process validation using the actual product. So we're going to be testing the critical to quality characteristics right throughout the batch. For a normal batch, we might mandate how many tablets we would test. During a process validation, we might test hundreds, and we might test them at much more frequent intervals than we would in a regular batch. So we might test the start times at T0, 1, 2, 3, 4, 5, for example. We might take a number of tablets there and test the characteristics at each of those time points. We might do it every 15 minutes to make sure that as the process is ongoing, that the characteristics are not diminishing or changing. We might check it after a major setting change to see how it's affected, after a major stoppage, again, seeing how it's affected, and run all of those tests in the lab. And again, at the end of the batch, we might look at the N-5, 4, 3, 2, 1, right up every minute until the very end of the batch stop time to see if there's any changes or if there's any effects of the end of a batch. We might check to make sure that the critical to quality characteristics aren't being affected by coming to the end of a batch run. The influence of the tablet hardness, really why the tablet hardness is so important is because it affects the dissolution profile. So when you dissolve a tablet, how it dissolves and where it dissolves in the body is obviously critical to quality. So the influence of the tablet hardness, so your dissolution profile, what you would do in the lab is you would take your tablets and you would drop them into a water bath and you would monitor the time point that they're supposed to dissolve on. You would take the sample at that time point and analyze it to see how much active ingredient has been released into the water bath for that time point. And that would give you a dissolution profile. That's obviously really important because that tells us where and when in the body the tablet will release its active ingredient. That's quite closely related to the disintegration because obviously we need the tablet to disintegrate at a certain point in the body as well, and that's a critical to quality characteristic. Tablet friability is if we put force onto the tablet, how likely is it to crack and have chips coming off of it and break down. And obviously we want our tablets to be pretty robust, that they're not going to break and chip during processing or in the pharmacy before it gets to a patient, because if there is chips gone out of your tablets, obviously your patient is not getting the full amount of active ingredient that they have been prescribed. So that would be an important critical to quality characteristic as well for a tablet. So how did you do? How many of the critical to quality parameters were you able to identify up front? And were you able to identify most of the qualification activities? I hope you were, and we'll see you again for the next lesson. Thank you for your attention.